Good day everyone. So for our topic for week 8 is scientific notation. Scientific notation. It is a system of notation used to express very large or very small numbers conveniently. This is used for us to present very large and very small numbers easily. Next, it uses exponents so as not to require the use of many zeros, which can be confusing and lead to errors. Writing very large or very small number were sometimes confusing because of many zeros, but here, scientific notation uses exponents for us to prevent errors in writing very large or very small numbers. Next, a scientific notation is written in the form of a times 10 raised to n, where a is greater than or equal to 1 but less than 10. So let us see how are we going to know the appropriate exponent in expressing numbers using scientific notation. So it is written as a number from 1 through 9 multiplied by 10 raised to the appropriate exponent. Okay, let us have here the illustrative examples for scientific notation. So let us have number 1. The distance of the Earth from the Sun is approximately 93 million miles. Write the distance in scientific notation. So for our solution, move the decimal point of the original number, 93 million, to the left until the first significant digit to the left of the decimal point and copy the significant digits to its right. So that would be 9.3 and then 6 zeros is equal to 9.3. So count the number of places you have moved the decimal point. So you have moved 7 places to the left and multiply 10 raised to that exponent. So the exponent is positive. Since 10 raised to 7, we convert a large number to scientific notation. So therefore, 93 million is equivalent to 9.3 times 10 raised to 7. Take note that the decimal point of a whole number is always at the end of the number. So if we have here 93 million miles, the decimal point of that is at the end of 0. The last 0. So you already move the decimal point to the left 7 places. So that will be 9.3 times 10 raised to 7. Let us have number 2. Write 0.00000000734 in scientific notation. So for the solution, we are going to move the decimal point of the original number. This is the original number to the right until the first significant digit to the left of the decimal point and copy the significant digit to its right, that is 7.34. So we are going to move this decimal point going to the right for us to find the non-zero digit. So that is 1, 2, 3, 4, 5, 6, 7, 8, and then 9. You move the decimal point going to the right 9 places. So count the number of places you have moved to the decimal point, that is 9 places, and multiply 10 raised to that exponent. The exponent is negative since 10 raised to negative 9. We convert a small number to scientific notation. So therefore, the given is equivalent to 7.34 times 10 raised to negative 9. Take note, if our given is a small number, our answer or our exponent must be negative. Number 3, write 4.7 times 10 raised to 8 in decimal form or standard form. So let us have here our example is 4.7. For us to make the given to become a large number, because our exponent is positive, so we are going to move the decimal point going to the right 8 places. So this is the decimal point, 1, 2, 3, 4, 5, 6, 7, 8. So just add the necessary zeros that we need. So that is the solution for this. So summarize that. Our answer is 470 million. Move the decimal point to the right the same number of places as the exponent, adding zeros as necessary. So the positive exponent indicates a large number. So we get the answer, which is a large number. Therefore, 4.7 times 10 raised to 8 is equal to 470 million. Example number 4. Write 2.51 times 10 raised to negative 5 in decimal form or standard form. Our exponent is negative 5, so our answer should be in decimal form. So we have 2.51. For us to make this as very small number, we are just going to move the decimal point 5 places to the left. That is 1, 2, 3, 4, 5. So just add the zeros and then the decimal point. Okay, so to summarize that solution, so that is 0.0000251. Move the decimal point to the left, the same number, places as the exponent, adding zeros as necessary. The negative exponents indicate a small number. Therefore, 2.51 times 10 raised to negative 5 is equal to 0.0000251. So we have 0 point and then 4 zeros, 251. Remember, if the number is large and you want to express it in scientific notation, what must be the sign of the exponent of 10? So the sign of the exponent is 10 is positive. Next, if the number is small, what must be the sign of the exponent of 10? So the sign of the exponent of 10 is negative. How do you change scientific notation to decimal notation? So if the sign is negative, converted that into decimal notation, you are going to move the decimal point to the left. Next, if the exponent is 10 is positive, where should you move the decimal point? So you're going to move the decimal point to the right. It depends on what is the exponent of 10. Next, if the exponent is negative, where must be the decimal point be moved? So if the exponent is negative, you are going to move the decimal point to the left. Okay, that would be all about scientific notation. If you do have questions, just comment your question in my YouTube video. Thank you. Don't forget to like, share, and subscribe. Thank you.